Assalamu alaikum. Today we will represent our project on analyzing inflation using network science techniques applied to consumer price index data from PBS Pakistan Bureau of Statistics. Our dataset consists of 3 consecutive years of monthly CPI data collected across multiple major cities in Pakistan. Each dataset originally came in raw Excel formats or even in PDF formats in some cases, where different cities and items were distributed across multiple sheets. The first step of our methodology was obviously data pre-processing. We cleaned the dataset by handling missing values, removing inconsistencies, and standardizing item names across all cities to ensure uniformity. This was important because even a small naming difference could break our analysis. Next, we transform the dataset from wide format into long format, where each row represents a single item in a specific city at a specific month or time of the year. This reconstructing of data made it easier to apply computational analysis and vector-based operations. For feature construction, we focused on capturing behavior of prices over time rather than their absolute values. Since each year contains 12 months, we computed 11 month-to-month price changes for every item in every city. These changes were then represented as these changes were then represented. Okay, let me share the screen again. Okay, these changes were represented as 11 dimensional vectors. Each dimension corresponds to relative price movement between consecutive months. This step is critical because it allows us to compare items based on their price trends independent of their scale. So by applying these techniques, we formed the foundation of our similarity computation and subsequent network construction. Now Wasif will guide us on the next step.
So for the similarity, we computed the similarity threshold, cosine similarity threshold for each of the nodes, and then we set a tau value. It was default at 0.5 to it was basically a cosine similarity threshold, the maximum value that can be attained. Then another parameter that we set for the similarity was a k value. K was the number of cities in which the tau value has been reached or the cosine similarity has been achieved in those nodes. Okay, so using these conditions, we constructed unidirectional graphs, unidirectional graphs, where nodes represents consumer items, edges represents strong similarity relationship. We implemented this using Python and Network X library, which allowed us to efficiently build and analyze the network structure. Now moving on to Moin.
Okay, let me put that to Moin's part actually. Okay, Moin, you may continue.
To identify influential items in the network, we computed centrality measures, particular betweenness centrality. This metric identifies items that act as bridges in the network. A high centrality value means that the item plays a key role in transmitting price changes across different sectors. Our results showed that fuel-related items, especially high-speed diesel, consistently had the highest centrality values. This indicates that the fuel acts as a major inflation anchor affecting multiple categories. In contrast, items like garlic or bananas show near zero centrality, meaning they have limited influence on the broader network. Now we will move toward our implementation. Let's
Okay,
move to that screen.
okay, let me move to the code. Yes, Moin.
Now we briefly demonstrate our implementation. Here we load the clean dataset and generate feature vectors. Next, we compute cosine similarity between all item pairs, as you can see on the screen. Using our threshold tau is equal to 0.5 and k is equal to 8, we constructed the graph. Finally, we visualize the network and compute centrality matrix using network X. This allows us to observe how different items are connected and identify key influential drives. Now we will move toward Wasif.
Okay, Vasif, let me put your part on. Okay. Okay,
Okay, so
Vasif.
for analysis, we compared graphs under different similarity thresholds and weeding scheme. We observed that increasing the threshold tau reduces the number of edges. That means that there was a strong, they set the relationship to a very strong heights and less number of edges were achieved. Under these weighted graph, edges reflect the strength of similarity, which means that the similarity of two items and their trends across case cities actually, which change the centrality ranking of item. Across the 3 years, we identify a major structural shift. Earlier, networks was more clustered while recent networks became more interconnected. This indicates that inflation is becoming more system-wide, with shocks spreading more rapidly across sectors. Overall, fuel items consistently remain dominant, confirming their role as key inflation anchors. Moving on to Moin's part.
Let us end our demo here.
Yes,
And
Vasif, all is covered. Thank you very much for watching our demo.
Allah Hafiz, keep us in your prayers.